Hey guys, welcome to this session on natural language processing. Today we'll start off by understanding what exactly is NLP. Then we'll understand what is tokenization and learn how to tokenize words with NLTK package. After that, we'll learn about different concepts in NLP such as stemming, lemmatization, POS tagging, and named entity recognition and implement each of them using NLTK. Going ahead, we'll work with the spacy package to implement some NLP concepts. And finally, there'll be a quiz to recap whatever we've learned in today's session. So let me start off by asking a very simple question. What do you understand by the term natural language? Well, simply put, natural language is any language which has evolved naturally in humans. So any of these languages, English, Hindi, French, Telugu, or any of the numerous languages which has evolved naturally in humans through use and repetition without conscious planning can be termed as natural language. Now, since we're humans, we're able to comprehend these languages. But what about a machine? What if these same languages are fed to a machine? Will it be able to comprehend them? So this is where natural language processing comes in. So natural language processing is the ability of a computer program to understand and interpret human language as it is spoken. Or in other words, NLP is used to gain knowledge from the raw textual data at our disposal. Now let's go ahead and look at the components of NLP. So NLP can be basically divided into natural language understanding and natural language generation. So let's start with natural language understanding. So NLU, as the name states, deals with understanding the input given in the form of sentences in text or speech format. And this is where the machine analyzes the different aspects of language. Then we have natural language generation. So NLG deals with turning raw data into simple human understandable language, or in other words, producing natural language from raw input. Now to implement the NLP concepts, you would need some packages tailor-made for natural language processing. So in today's session, we will work with two such packages which are NLTK and spacy. So generally the first step in NLP process is tokenization. So in tokenization, we basically split up our text into individual units and each individual unit should have a value associated with it. So let's take this example. We have a sentence, Joey doesn't share pizza, and we are splitting this up into individual tokens where each word is taken as a separate token and also the exclamation marks are taken as separate tokens. Now, we can use these tokens for another process like parsing or text mining. So let's actually head on to a Jupyter notebook and learn how to tokenize a sentence using the NLTK package. So we'll start off by importing NLTK and NLTK.corpus. I'll run this. After that, we would require the word underscore tokenize function from the NLTK.tokenize package. So we'll also import this function from NLTK.tokenize. I'll click on run. So over here we have a string. So after surprising the host in the first test, Sri Lanka made a positive start to the second test. So this is the entire string over here and I am storing it in an object named as cricket. Now what I'll do is I will pass in this object inside the word tokenize function and I will store the result in cricket underscore tokens and I will print this out. So this is the part where we are basically tokenizing this entire string into individual tokens with the help of this word underscore tokenize functions. So I'll click on run. Right. So we see that this entire string is split up into individual tokens. After is one token, surprising is token, the is token, host is token. So again, we've taken up this entire string and split this up into individual tokens. Now, after doing that, let's also have a glance at the type of this and the number of tokens we have. I'll click on run. So you see that this is a list of all the tokens and we have 201 tokens in total. Now let's also get the frequency of these tokens. That is, I want to find out the number of times each token value occurs. And for that, I would require the frequency dist from NLTK.probability package. So I'll import this and I will create an instance of this with the name fdist. Again, I'll click on run. Now I will create a for loop where this I value will iterate through all of the tokens, and for each token I will keep on adding the count wherever it is encountered, and finally I will print this out, which is fdist. So I get the frequency of all the tokens over here. So see that the occurs 11 times, comma occurs 8 times, A occurs 6 times, for occurs 6 times, South and Africa occur 5 times, right? So this basically is the frequency distribution of all the tokens. Now if I want to find out the 10 most common tokens, then I have this most common function. So I'll call fdist.mostCommon and I'll pass in the parameter which is 10. So this will give me the 10 most common tokens and I'll store it in top 10 and I'll print it out. I click on run. So these are the 10 most common tokens. So the is the most occurring token which occurs 11 times. Now, human beings can understand linguistic structures and their meanings easily, but machines are not successful enough on natural language comprehension yet. So, when a machine has to parse through one word at a time, it may not be able to fully understand semantics of a sentence. And these words, when given one at a time, are known as unigrams. So let's take this language over here. I love natural language. And when each of these tokens are given one at a time to the machine, this is nothing but a unigram. I love natural language. So these are basically unigrams given to the machine. And similarly, when the machine is given two words at a time, it is known as a bigram. So this is a bigram. I love natural language. So this entire sentence is basically being given in the form of two tokens at a time. And similarly, when this entire sentence is given three words at a time, it is known as a trigram. So this time it is split like this. I love natural is one part, and then we have love natural language, right? So this is the trigram which we have over here. So again, let's head back to Jupyter Studio and learn how to create bigrams and trigrams. So over here we have this sentence. Did you know there was a tower where they look out to the land to see people quickly passing by? And I stored this in black smoke. So I'll just quickly hit on run. And now I will tokenize this sentence with the help of the word tokenize function, and I will store this result in black smoke token, and then I'll print it out. I'll click run. So these are the individual tokens from this entire sentence which we have over here. Now, if I want to create bigrams and trigrams from this, we have the nltk.bigrams and nltk.trigrams function. So I will use this nltk.bigrams function and then pass in these individual tokens inside this function, right? So I am passing this black smoke token object inside the nltk.bigrams function, and I want to see the result in the form of a list. So I click on run, right? So now these individual tokens are being represented in the form of bigrams. Did you know there was. Similarly, if I want to represent these tokens in the form of trigrams, I will use the nltk.trigrams function and then pass in this object which is black smoke token. Again, I'll hit on run. Now we have trigrams. Did you know there was, right? And finally, we have something known as n-grams. So n-grams basically has an additional parameter over here. So if I want 4 words together, I'll put in 4. If I want 5 words together, I'll put in 5. Similarly, if I want 10 words together, I'll just put in 10 over here. So for that, I'll have to use the nltk.ngrams function. And the first parameter inside that would be the list of tokens. After that, the parameter which would tell us the number of words together. And this time, I want to see 4 words together. I'll put in 4 and then I'll click on run. Right, so over here we have 4 words together. So now let's understand stemming. So stemming is the process of reducing a word to its base form. And this is done by cutting off the beginning or ending of the word. So this indiscriminate cutting will be successful in some occasions and fail in other. So let's take these 3 examples over here. So this first case, studies, we have cut off the suffix es and it becomes study. And the second case, giving, we have cut off ing and it becomes giv. And in the third case, we have cut off ing from buying and it becomes buy. So in all of the 3 cases, we see that only in the third case, we have a word which makes sense. So when we are implementing stemming, it is always not necessary that the final stemmed word which we get should have a meaning associated with it. Now there are many stemming algorithms available. So one such stemming algorithm is Porter stemmer, and we'll be importing this Porter stemmer from nltk.stem package. After that, I will create an instance of this Porter stemmer with the name PST. I want to stem these three words over here: winning, studies, and buying. So I will pass in these three words inside pst.stem. So pst is the Porter stemmer instance, and this instance basically has the stem function. So I want to stem the word winning, the word studies, and the word buying. I'll hit on enter. So I just have to run this first. Now I'll click on run again. Alright. So you see that winning has been stemmed to win, studies has been stemmed to study, and buying has been stemmed to buy. Now, similar to stemming, we also have lemmatization. So lemmatization is the process of reducing words into their lemma or dictionary. So the base form into which the word is converted should definitely have a meaning associated with it. So again, we have three cases over here. Studies is converted to study, which obviously has a meaning. Giving has been converted to give. Similarly, buying has been converted to buy. So see that these three individual base words have meaning associated with them. Now to implement lemmatization with the help of NLTK package, you would need the WordNet and WordNet lemmatizer. So we will be implementing these two from nltk.stem packages. And I will create an instance of this WordNet lemmatizer. Now, what I want is, I want the lemma forms of these three words: cats, cacti, and geese, and I will store this in this object words to stem. So after that, I will basically create a for loop which will go through these three words and lemmatize each of them. I'll hit on run. Right, so you see that cats has been lemmatized to cat, the lemmatized version of cacti is cactus, and finally the lemmatized version of geese is goose. Now, another important concept of natural language processing is parts of speech tagging. So in the English language, words can be considered as the smallest elements that have distinctive meanings, and based on their use and functions, words are categorized into different classes which are known as parts of speech. So POS tagging is the process of marking or tagging every word in a sentence to its corresponding part of speech. So let's take this sentence: Joey loves pizza. Now we can mark each of this word with a POS tag. So the word Joey is a noun, loves is a verb, and similarly pizza is a noun again. So we'll be adding POS tags to this sentence over here. What do you mean I don't believe in God? I talk to him every day. And I've stored this in this object peace. Now again, first task would be to tokenize this sentence. So I will use the word underscore tokenize function and pass in this object, and I'll store the result in peace tokenize. So let me execute these two. Now I will start a for loop which will iterate through all of the tokens, and for each of the token I will add a POS tag with the help of this POS tag function. So I will use this nltk.POS tag and add a POS tag to each of the individual tokens from this piece tokenized list. I'll click on run. Right. So you see that each of these individual tokens has been marked with a POS tag. So what has a POS tag of WH pronoun, do has a POS tag of verb, you has a POS tag of personal pronoun, and mean has a POS tag of noun, right? And similarly we have these POS tags for the rest of the tokens. Now let's also add POS tags for another sentence over here. So this sentence is: Mary had a little lamb whom she really loved, and we are storing this in the object Mary. Now again I'll use the word underscore tokenize function and pass in this object, and I'll store the result in Mary underscore tokenize. After that, I'll use this for loop which will iterate through all of the tokens and add a POS tag to each of the tokens. I'll hit run, right? So Mary is a proper noun, had is a verb, a is a determiner, and similarly we have other POS tags associated with each of the words. Moving ahead, we'll understand what is named entity recognition. So, named entity recognition is the process of taking a string of text as input and identifying relevant nouns such as people, places, and organizations that are mentioned in that string. So, in the sentence, Apple buys UK startup for $1 billion. Apple has been recognized as an organization, UK has been recognized as a geopolitical entity, and $1 billion has been recognized as money. Now, one thing to be noted over here is all these three words are nouns. So, named entity recognition is done only on nouns. And to do named entity recognition, we would require this any underscore chunk function. So, we'll import this from the NLTK package. I'll hit on run, and we would want the named entity recognition for this sentence over here. John lives in New York. I'll store this in John. Again, the first task is to tokenize this sentence. So I'll use the word underscore tokenize function and pass in this object John inside this. I'll store it in John underscore token. I'll click on run. Right, so we have tokenized this. After that, we will add a POS tag with respect to each of these tokens. So I'll use the function nltk.pos tag and pass in these tokens, and I will store this in John tags, and I'll print this out. Right. So we have a POS tag associated with each of these tokens. John is a noun, lives is a verb, N is a conjunction, right? Now finally, it's time to get the named entity recognition of these POS tags. So I will use the any underscore chunk function and pass in this John underscore tags object inside it, and I'll store it in John underscore ner. After that, I'll print it out. Right, so you see that John has been recognized as a person. Similarly, New York has been recognized as a geopolitical entity. Again, the thing to be kept in mind is the named entity recognition is done only on nouns. John is a noun, New York is a noun, right? So that is why John has been recognized as a person and New York has been recognized as a geopolitical entity. So all of those tasks were done with NLTK. Now we also have spacy, which is a relatively new framework in the Python natural language processing environment, but it will quickly gain ground and will most likely become the de facto library for natural language processing. So spacy is written in Python language, that is C extension of Python, which gives C-like performance to the Python program. So let's go ahead and import the spacy package. Now the spacy package has different models. So we'll load the EN core web small model and store it in NLP object. I'll hit on run. Right. Now using this NLP object, I can create different documents. So these documents basically contain strings. So each string can be classified as a document. So I will store this is Pata. Inside this document, I'll click run. Now, so tokenization is very simple when it comes to a spacy package. So all I have to do is start a for loop and print all of the tokens present in that document. So for token in doc, so it will iterate through all of the tokens present in the doc and print the text of all of the tokens. I'll hit run. Right. So these are the 5 tokens which are present in the string. This is Sparta, and then we have 2 exclamation marks. Now after that, let's see if I want to get the third token from this. So if I want to get the third token, then that is present at index number 2 of this document. So 0, 1, 2. So that is why I'll pass in doc and I will give in the index number which is 2 and I'll store this in token. Right? So the third token is Sparta. Similarly, if I want all the tokens present at second, third and fourth indexes, so I can use this. So inside the parenthesis of doc, I will start at 2 and I'll end at 5. So this will basically give me all the tokens starting at second index and ending at the fourth index. Now let me go ahead and print the token index and the token text together. So this is a document. This is Sparta. Now in this print command, I am first printing the token index, which I get with the help of token.i. After that, I am also printing the tokens text, which I get with the help of token.text. Right? So I have the token index and I have the corresponding token text to each of these index values. Now similarly, let me also do POS tagging with the spacy package. So for that, the document is Joey doesn't share pizza, and I will iterate through all of the tokens in this document. First, I will print in the index of the token. After that, I will print in the text of the token, and finally, I will print the POS tag of these tokens, right? So we have the index value, we have the token text, and we also have the POS tag corresponding to each of these tokens. Now similarly, we can also do named entity recognition. So for this, we have the string Apple is looking to buy UK startup for $1 billion. And obviously I've stored it in this doc object. I'll click on run. And over here we have this for loop for ent in doc.ents will print out the entity's text and also the corresponding entity label. So basically doc.ents comprise of all the entities and the corresponding labels with respect to the entities recognized. So I'll hit on run. Right. So this doc.ents has recognized these three entities. Apple has been recognized as an organization. UK has been recognized as a geopolitical entity, and $1 billion has been recognized as money. Barack Obama, the former president of United States, will be vacating White House today. I'll click on run. Again, I'll start the for loop and I will print the entity and the corresponding entity recognition. Right, so Barack Obama is recognized as a person, United States is recognized as GPE, and today has been recognized as day. And finally, we have also something known as matcher from spacy. So this matcher helps us to find patterns in a string with different criteria, such as understanding the lemma of the word, understanding if the word is a digit or not, understanding if the word is a punctuation mark or not, so something like that. So let's do some pattern matching on the string over here. Barack Obama, the former president of United States, will be vacating White House today. Again, I will store this in doc. So now, first I will create a pattern. So pattern is basically created as a list of dictionaries. So each dictionary indicates a word. So the first word we are basically trying to match with the lemma value. So the first word's lemma should be vacate. And after that it needs to be followed by another word which is white, right? So I want to extract a substring from this entire dog, which is basically two words. The first word is a lemma variation of vacate and the second word is white. Now I will create an instance of matcher by passing in nlp.vocab inside this. Now this matcher instance has this add function which basically takes in three parameters. First parameter is the ID, which helps us to uniquely identify this pattern matching. After that, the second parameter is basically the callback function, which I have stated as none over here. And the third parameter is the pattern which I want to identify from the string. So I've given these three parameters. After that, I will pass in the document inside the matcher function and I will store it in matches. I'll hit run. Now, this matches object will basically comprise of three things: match ID, start index, and the end index. And I will put these three inside the for loop and get the substring from this document. So I'll hit on run. Right. So I have successfully extracted vacating white from this entire string over here. So the pattern basically was the first word needs to be a lemma variation of vacate and it needs to be followed up with the word white. Now similarly, let's also do pattern matching on this string over here. 2018 FIFA World Cup, France won. I'll click run. So this time the pattern matching should be something like this. The first word should be a digit, second word should be FIFA, third word should be world, and the fourth word should be cup. Again, I will create an instance of this matcher and I'll pass nlp.vocab inside this. After that, I will use the add function and give these three parameters. So ID is FIFA pattern, second parameter is none, and the third parameter is basically the pattern which I want to extract from the string. And after that, I will use this match2 and pass in this document inside this and store the result in matches2. I'll click run. So again, I'll use this for loop and extract the substring from this original string. I'll click on run and I have successfully extracted the substring, which is 2018 FIFA World Cup, from this original string over here. Right, so this is how we can implement NLP concepts with the help of NLTK package and spacy package.
Now let's head to the quiz.
So we have this sentence, this is para. Now what do you think? How many bigrams can be generated from this sentence? So these are the options. Think about it and write down the answer in the comment section. And this brings us to the end of the session. Thank you very much for attending.